Hello and welcome to Chem 101. Make sure you have your notes and your conversion factor sheet out because today we're going to look at conversions. Couple of practice problems. One, we're going to find out how much blood your heart beats every beat in cups. Now we know the amount in liters, but we're not really used to working with liters. So let's change it to cups so we can visualize how much blood your heart is pumping every beat. To do this, we're going to go through our 6 conversion steps. Now you should have these in your notes. So for this problem, remember our first step is to know our conversion factors. And in this case, for this problem, I gave them to you. So we just need to make sure we recognize them. I'm just going to put a CF by each of them so I know those are probably going to be conversion factors because I have 2 things that are equal to each other. The other number I have in my problem is the 0.700 liters. That's probably going to be my starting point because it's not a conversion factor. Once we figure out what we're starting with and we've identified our conversion factors, we need to figure out where we're headed. What are we looking for in this problem? Well, we're asked to convert the amount of the volume of blood into cups. So I'm going to be looking for cups. That tells me when I'm done with the problem. Once we had that set up, now we can do our relationships between our units. So we know we are going to start with 0.70 liters. I'm going to do my conversion factor signs, and I'm just going to work with the units. I know I have to get rid of liters. Remember, my final destination is cups. I don't have anything that directly relates liters and cups, but I do have something that relates liters to quarts, and I have something that relates quarts to cups. So I'm going to take this to quarts, but I don't want quarts, so I'm not going to stop. I'm going to keep going. I'm going to get rid of quarts, and I'm going to go to cups. I check my units to make sure I've set it up correctly. My liters will cancel, my quarts will cancel, and I'm left with cups. That tells me the problem is set up correctly. Remember, we don't want to stop in the middle because that can cause rounding errors when we do our sig figs. So now I'm ready to plug in my numbers. From each one, I have to take the number from the equality. I can't use a number I already have. So remember that 0.70? I'm never going to rewrite that number. I have to get new numbers based on my conversion factors. So with the quart, keeping the unit with the quart, the 1.057 has to stay with the quart, and the 1 has to stay with the liter. The 4 has to stay with the cup, and the 1 has to stay with the quart. Once I have my numbers filled in, remember my next step is to do my math correctly and punch it in my calculator correctly. Remember, we punch in multiply for any number that's on top, divide for any number that's on bottom, and we don't have to enter ones because they won't affect anything. So punch this in your calculator. 0.070 times, because this is on top, 1.057 times, you don't have to hit equals, 4. If you punch it in your calculator correctly, you should get 0.30 cups. That's how much blood your heart pumps every time it beats. Now, we're not done yet. Remember, we have one more step. We have to check our sig figs. Remember that our conversion factors that we would have memorized don't affect my sig figs. So in this case, this is the only number I have to look at. 7 is significant, 0's in front, don't count them, 0's at the end. I have a decimal, so yes. 2 sig figs, don't count the 0's in front, 3, 0, 2 sig figs. I've written my correct answer with the correct units. Now, before we do another problem, let's look at this with the nursing method. Remember, for the nursing method, you can use colons to compare things, but you can only do one at a time. We can say that 0.070 liters is to some number. We can't go directly to cups. I still have to figure out where I'm going to stop. So we're going to go to quarts first. It's to some number of quarts as 1 liter is to 1.057 quarts. Remember to keep the units together. If you do liters first here, you have to do liters first here, then your quarts. As long as you keep them lined up, this method will work. Then we're going to multiply our inner ones and our outer ones and set them equal to each other. So I would do 0.70 liters times 1.057 quarts, and that will be equal to 1 liter times my question mark quarts. So notice I'm just going to multiply the 0.70 and the 1.57. I would divide by 1, but dividing by 1 isn't going to affect anything. When you do this, that gives you the first step, and you should end up with 0.07399 quarts. Don't round to sig figs at this point. Wait until you've completely finished the problem. Now I have quarts. Now I'm going to do another relationship to go to cups. So again, I'm going to set it up with my colons, and I'm going to say 0.07399 quarts is to some number of cups as 1 quart is to 4 cups. Again, multiply our inners, multiply our outers, and set them equal to each other. So now we're going to multiply our inner terms and our outer terms again, and then solve our algebra like we did before, and you should end up with 0.30 cups, just like before. So either method would work, and I'll accept either method on a test or a quiz. But keep in mind for Chem 21, you'll need to turn them into conversion factors. Let's do a slightly more complicated problem now. We have a very long-looking word problem, but we need to take it apart and look at each piece, okay? So the first number I see is this 56 milligrams per kilogram per day. Now, if I read what's around it, this is the doctor's order. We're looking at penicillin and potassium. So this milligrams must be my milligrams of the medicine. My kilograms must be per kilogram of patient weight. Now I know that because it gives me the patient weight a little bit later, okay? In 4 divided doses for a patient weighing 50 pounds. So again, this is my patient weight. Now I'm giving them this much medicine per day. So this is a timing component. But it also tells me I want it divided into 4 doses. I'm not going to give them the whole batch of medicine at one time. So this is my number of doses. Whew, that's a lot of numbers so far, and we're only halfway through the problem. We're then told that the medicine comes in 125 milligrams. Now, which type of mass is this? Is this my mass of my medicine or my mass of my patient? I have to keep those masses separate. In this case, this is going to be my medicine, okay? And it comes 125 milligrams in every 5 milliliters. Now that we've identified all the numbers that we have, what are we actually looking for? It asks us for the volume in milliliters, so this is my question mark, that I'm administering in each dose, not per day, but per individual dose. Now we're ready to set it up as a problem. But first, let me identify my conversion factors. The milligrams per kilograms per day, remember anytime we have that per, this means that these are probably going to be conversion factors. It's divided into 4 doses, and those 4 doses would be the amount per day. So I can probably label that as a conversion factor. 50 pounds isn't paired with anything, so that's probably not a conversion factor. 125 milligrams, 5 milliliters, those are paired, so those could be a conversion factor. And since we're looking for just 1 unit, I know I don't want to start with something that's a conversion factor that has units on top and bottom. I want to start with something that only has units on top. So I'm going to start with my patient's weight, because that's my first step in determining how much medicine to give them. So if my patient weighs 50 pounds, that's going to be my first starting point. I don't want pounds, so I know it immediately goes down here. Oh, but wait, pounds is mass, and we had 2 types of mass. So not only do I have to label this as pounds, but I have to label it as pounds of patient. If I want to get to the medicine, the only thing that connects my patient to the medicine is this 56 milligrams per kilogram. So let's see if we can go to kilograms of patient in order to connect it to the medicine. Remember, this per line means I can set this equal to 1 kilogram. So I have a conversion that has kilograms of patient per milligram of medicine. But I don't really want milligrams of medicine for my final answer. I want it to be in milliliters. So we're going to do another conversion, get rid of my milligrams of medicine, and go to milliliters of medicine. That looks pretty good. Let's start with that part. Notice that my pounds of patient will cancel, my kilograms of patient will cancel, and my milligrams of medicine will cancel. Now I'm ready to plug in my numbers. I have to go to the conversion factors that relate the two together. Now the kilograms per pound of patient isn't on my list, but that's one we've memorized, right? We have 2.2 pounds per kilogram. So I'm going to take my 50, and when I start plugging it in, I'll divide by 2.2. But let's set up the rest of the problem before we plug anything in. Otherwise, we can have errors due to rounding that are going to throw off our results. Kilograms and milligrams, kilograms of patient, milligrams of medicine came from this conversion factor. So a 56 goes with the milligrams and a 1 goes with the kilogram. Milligrams and milliliters was related by this conversion factor. So the 125 goes with milligrams and the 5 goes with milliliters. Now we're able to punch that in and solve that part. Once you get that answer, you're going to have milliliters of medicine, but that's for the entire day, because remember, this 56 milligrams was for the day. That's how much they get in one day. I don't want to give it to them all at one time though, remember? In one day, I want to do a certain number of doses. And I need the milliliters of medicine per dose, okay? Milliliters in each dose. Another way of saying that is per dose, okay? So I know I can do this as a conversion factor. Once I have my milliliters, I plug that in here. That's for one day. Days, in one day, I want 4 doses. So whatever I get for my milliliters of medicine, I have to divide that by 4. That will give me the amount per individual dose. I'll let you finish this problem, and you'll be able to check it in Chem 21 because it's one of your problems. Your numbers may be a little different, but the process will be the same. So I'll let you finish this one on your own. Good luck with your conversions and have fun.